October 14th, 1943. The fields outside Schweinfurt, Germany. The battle is over. Smoke drifts low across the churned, muddy ground. The silence that follows a great air combat is thick, broken only by the crackle of cooling metal. Oberleutnant Klaus Richter lands his battered Messerschmitt Bf 109 in a nearby pasture. The adrenaline has left him, replaced by a deep, bone-aching cold. He wears layers of wool beneath his leather flight suit, yet the frost of 30,000 feet seems to have penetrated his very bones. He approaches the enormous wreck. It is a Boeing B-17G, twisted and shattered, yet still massive. The twin radial engines on the left wing are still smoldering. Richter climbs into the jagged opening near the cockpit. The interior is a scene of violent chaos, but the construction itself is unlike anything he knows. He reaches for a control panel, looking for the crude, necessary mechanisms of war. His fingers brush against a duct, a thick, insulated pipe running along the bulkhead. He follows the piping to a small, louvered vent near the navigator station. He recognizes the system instantly. It is a manifold for distributing hot air bled from the engine's exhaust. A cabin heating system. The Americans, fighting thousands of miles from home, were flying into the frigid upper atmosphere with the incredible luxury of comfort. Richter pulls off a glove, touching the cold metal of the vent. The German defenses were fighting a desperate, essential war of survival. The Americans were fighting one of abundance. This tiny, overlooked detail, built into the heart of a devastating weapon, was the first chilling sign of a war already lost. This astonishing difference in capability did not emerge overnight. It was the inevitable collision between two fundamentally opposite doctrines of war. The United States entered the Second World War not with the intent of strategic defense, but with a philosophy rooted in industrial offense. The core of this strategy was called daylight precision bombing. Unlike the British Royal Air Force, RAF, which favored massive, demoralizing night raids on broad urban areas, the Americans believed they could win the war by surgically dismantling the enemy's ability to fight, specifically by attacking critical industrial choke points during the day. This doctrine hinged on the myth of the unarmed bomber. The initial design of the Boeing B-17, the Flying Fortress, suggested that its sheer speed, high-altitude ceiling, and dense armament, up to 13 heavy machine guns, would make it virtually immune to interception. The theory was simple. Fly in massive, self-defending formations, hit the target with precise Norden bomb sights, and return home with minimal losses. The reality, beginning with the first major missions into the European theater in late 1942, proved violently different. The initial American foray, the U.S. 8th Air Force, was established in England and began cautiously. Targets were initially coastal French U-boat pens, building confidence and refining tactics. But the heart of the Nazi war machine, factories, oil refineries, and ball-bearing plants, lay deep within Germany, often beyond the effective combat radius of any fighter escort available at the time. This meant that for the most crucial hours of the mission, the bombers were essentially alone, dependent entirely on their own firepower and formation integrity. The B-17 and its heavier cousin, the B-24 Liberator, became the workhorses of this effort. They were marvels of engineering, designed to fly higher and carry more than previous generations. But their most profound contribution was their mass production. The United States leveraged its staggering industrial capacity, turning assembly lines that once built automobiles into rivers of aircraft production. This commitment was not just about building planes. It was about building a war machine capable of absorbing immense losses while continually increasing the operational tempo. The American strategy was a direct challenge to the German concept of air defense. The Luftwaffe, focused on tactical support and defending the homeland from night raids, had not anticipated the unwavering American commitment to penetrating deep into the Reich in daylight. This shift forced the Germans to divert precious fighter resources from the Eastern Front and the Mediterranean to the defense of the fatherland, a strategic bleeding that would only accelerate. The men of the 8th Air Force were volunteers, dubbed the Mighty Eighth. They flew missions knowing the odds were stacked against them. Their tour of duty was initially set at 25 missions, a number few believed they would ever reach. They faced the triple threat of ground flak, coordinated fighter attacks, and the devastating, unseen enemy of the upper atmosphere. The environment of 30,000 feet was one of paralyzing cold, thin air, and profound psychological stress. The B-17, for all its armor and guns, was a fragile cocoon hurtling through a deadly environment. This is where the American approach to industrial design began to reveal its hidden advantage. An emphasis not just on destructive power, but on the capacity to sustain human effectiveness in an almost uninhabitable climate. Life at 30,000 feet, the cold front. For the bomber crews of the 8th Air Force, the environment itself was an adversary as deadly as any German pilot. Precision bombing required high altitude, typically between 25,000 and 30,000 feet. At these operational heights, the conditions were hostile and unforgiving. The air temperature routinely plummeted to $-50*\circ\text C $58*\circ\text of dollar or lower. In an unheated environment, exposed skin could freeze in moments. The air was thin, requiring crews to rely on oxygen systems from the moment they passed 10,000 feet. This combination of extreme cold and low oxygen created a constant physical drain. Gunners standing for hours in open waist positions or rotating turrets faced wind chill factors that could push the effective temperature even lower. The critical problem lay in the design compromises necessary for speed and firepower. The Flying Fortress was festooned with gun positions, waist windows, ball turrets, and nose apertures, each necessarily open to the elements, or thinly protected by lightweight plexiglass. To reduce weight and maximize range, the decision was made to not fully insulate the entire fuselage. This turned the bomber's interior into a flying refrigerator. American strategists understood that a man shivering violently, struggling with numb fingers, could not effectively operate a complex bomb sight or track a fast-moving enemy fighter. The doctrine of precision required precise human input. If the crew was physically incapacitated by the cold, the entire multi-million-dollar mission failed. The solution was not to build a perfectly pressurized or insulated cabin that would have added prohibitive weight and complexity. Instead, the B-17 incorporated sophisticated, albeit often unreliable, systems designed to mitigate the brutal cold. These included electrically heated suits, gloves and boots, and, critically, a bleed air system. This system routed superheated air from the engine exhaust manifold through ducts to key crew positions, particularly the cockpit and the bombardier station, where complex tasks required sustained fine motor skills and concentration. In contrast, the German fighter pilots of the Luftwaffe, such as Klaus Richter, operated under an entirely different set of constraints. Their Messerschmitt Bf-109s and Focke-Wulf FW-190s were machines of minimal weight and maximum performance. Every ounce was dedicated to speed, climb rate, and armament. Comfort was a costly, extraneous luxury. Their flight decks were cramped, Spartan cockpits where pilots relied solely on layered flight suits and self-discipline to endure the high-altitude cold during their relatively short interception bursts. This difference highlighted a fundamental disparity in national resources and industrial philosophy. The United States possessed the raw materials, the manufacturing excess, and the logistical depth to incorporate systems for crew comfort and survivability. Systems that enhanced combat effectiveness not through direct destructive power, but through human resilience. The heated cabin, seemingly a small comfort, was a tangible expression of American industrial dominance. It allowed their crews to fly longer, higher, and maintain tactical concentration that their German counterparts, fighting the war in stripped, frozen cockpits, could scarcely imagine. The stage was set for the critical engagements of 1943, where the limits of both the German fighter defense and the American doctrine of unescorted deep strikes will be tested to the breaking point. The reality of this immense difference would soon be brutally revealed over the crucial industrial targets of the German heartland. The B-17 Flying Fortress was powered by four mighty Wright R-1820-97 Cyclone radial engines. These were not merely sources of propulsion. They were the heart of the bomber's complex electrical and pneumatic systems. The German focus was on extracting maximum horsepower for speed and climb from their engines, such as the Daimler-Benz DB605, for brief, violent attacks. The American design emphasized sustained power output and, crucially, secondary utility. The cabin heating system was a perfect example of this philosophy. It functioned by taking advantage of the intense heat generated by the massive engines. Specifically, it used a heat exchanger system. Exhaust manifolds, carrying superheated exhaust gases, were encased in jackets. Fresh air, pulled from outside the aircraft, was routed through these jackets, heated without mixing with the toxic exhaust, and then ducted into the crew compartments. This was a simple, yet highly effective technological feature that required significant material and engineering commitment. It necessitated extra ducting, insulation, and the complexity of maintenance. For a German designer, obsessed with weight reduction for peak fighter performance, dedicating precious material and engine power to crew comfort would have been seen as strategically wasteful. For the Americans, it was a necessary investment in preserving the capability of a highly trained, expensive 11-man crew. The heater was not a luxury. It was a force multiplier, ensuring that the men manning the guns and the bomb site remained effective, alert, and capable of operating the complex machinery under duress. The American doctrine of daylight bombing was entirely dependent on the combat box formation. This tactical geometry was the physical manifestation of the belief that the B-17 was its own best defender. The box was not a loose scattering of aircraft. It was a tightly choreographed, three-dimensional array of bombers, staggered vertically and laterally. The purpose was to create interlocking fields of fire. Every heavy machine gun on every B-17 covered the vulnerable areas of its neighboring aircraft. A German fighter attempting to penetrate the box would instantly find itself flying into a combined crossfire of dozens of .50 caliber machine guns. This mass defense was statistically effective, forcing German pilots to attempt their attacks from increasingly difficult angles and distances. The rigidity of the combat box, however, presented significant challenges. Maintaining such a tight formation for hours in extreme weather and turbulent skies was physically and mentally exhausting. It increased the risk of mid-air collision, especially in clouds. Furthermore, once a fighter escort was forced to depart due to fuel limitations, the formation became the only shield. The discipline required to fly wingtip to wingtip was immense, and the crew's ability to maintain focus, despite the noise, vibration, and cold, was paramount. The very systems of crew comfort, including the heated air, supported this tactical necessity, ensuring the pilot's hands remained responsive on the controls and the gunner's attention did not falter due to physical distress. The German fighter pilots, led by tactical innovators like Major Gunther Lutzow, quickly recognized the weak points in the seemingly impenetrable B-17 formation. The American doctrine emphasized firepower to the rear and sides, expecting pursuit attacks. The nose, particularly the frontal aspect where the pilot and bombardier sat, was initially less protected. The favored Luftwaffe tactic became the head-on attack. German fighters would form up en masse, often using the cover of cloud banks, and dive directly through the bomber formation from the 12 o'clock position. The closing speed of the B-17 and the interceptor was often over 500 miles per hour, leaving the German pilot only a few seconds to aim, fire, and break away. This reduced the time the B-17 gunners had to react and minimize the exposure of the German aircraft to the overwhelming defensive fire. To counter the thick armor and self-sealing fuel tanks of the American bombers, the Luftwaffe also escalated their armament, moving from standard cannons to heavier 20mm and 30mm ordnance. Some units experimented with air-to-air rockets. This escalating arms race, however, forced the German aircraft to carry more weight, reducing their flight endurance and climb rate. It was a trade-off, more destructive power for less time in the fight. The sheer number of American aircraft meant the Luftwaffe needed to inflict crippling losses quickly, but the depth of American industrial production meant that for every bomber they shot down, 2 more were already rolling out of the factories. This strategic dilemma only deepened the German pilots' frustration, which was compounded when they began to observe the stark difference in crew conditions. Angle 4. The arsenal of democracy, quantity as a weapon. The true shock of the American bombing campaign for the German leadership and its pilots lay in the sheer, relentless quantity of the attack. The German war economy was a focused, mobilized effort, but it was structurally fragmented and constantly competing for limited resources. Production of the Bf-109 and Fw-190 was steady, but constrained by the supply of essential materials like aluminum and high-octane fuel. The American production machine, conversely, was a genuine arsenal of democracy. Leveraging a vast, untouched industrial base and abundant natural resources, the United States achieved unprecedented rates of output. By 1943, new B-17s were being delivered to England faster than the Luftwaffe could shoot them down. This was a war of attrition fought on a scale the Reich could not match. The American industrial output prioritized ease of manufacture and repairability alongside combat capability. The heated cabin, the electric suits, and the complex array of defensive guns were simply factored into the cost of production, a cost the American economy could bear without strain. German manufacturing, driven by necessity, often resulted in aircraft that were sophisticated but complex, relying on highly skilled labor and often suffering from quality control issues as resources became scarce. The American approach was one of standardized, mass-produced resilience, where the loss of one aircraft was a logistical setback, not a strategic catastrophe. This difference in scale provided the psychological foundation for the crew comforts. They were built into an aircraft that the American system was designed to produce indefinitely. For the individual airman, the difference between the two air forces was visceral. The American bomber crewman, even facing the terrifying gauntlet of flak and fighters, was operating in a system that strove to preserve his physical effectiveness. The heated cabin in the nose, the padded seats, and the electric suits were not about morale. They were about maintaining the fine motor control necessary to hold the aircraft steady or operate the precision Norden bombsight. In the German cockpit, the environment was fundamentally different. The Bf-109 and Fw-190 were designed with a minimalist, Spartan philosophy. The pilot sat on an often uncomfortable, utilitarian seat, surrounded by essential gauges and levers. His sole protection from the cold was his heavy flight suit and the layers beneath. Crucially, the short duration of a typical interception mission, often less than an hour, made extensive environmental controls seem unnecessary to the designers. The German pilot was expected to endure the discomfort as part of his duty. When a German ace like Richter examined the captured B-17, the heated cabin became more than a piece of plumbing. It became a profound psychological symbol. It represented a world of resources and engineering mastery that the German war machine, already strained, could only dream of. The Americans were not just fighting a war, they were fighting a war of affluence. This realization undermined the foundational belief in German technical superiority and challenged the psychological resolve of the pilots, who recognized the imbalance. They were fighting men who were fighting in relative comfort, a concept that exposed the deep logistical vulnerability of the Reich. The moral dimension of the unescorted deep raids was enormous for both sides. The American crews were asked to fly into the heart of the enemy without guaranteed protection, relying only on their tight formation and the firepower of their flying fortresses. The 25-mission tour became a grim lottery. The high losses, particularly in the summer and fall of 1943, created a climate of profound stress, yet the missions continued with unflinching regularity. For the German pilots, the constant, deep penetration of American bombers was a direct assault on the concept of the inviolable German homeland. They were hailed as the defenders of the Heimat, homeland. The psychological pressure to stop the B-17 formations, often against overwhelming odds and an outdated aircraft, led to immense exhaustion and despair. The sight of a destroyed B-17, though the victory, also revealed the enemy's endless supply and their baffling capacity for mechanical luxury. It was a constant reminder that the enemy's resources seemed limitless, a psychological anchor pulling down the belief that the war could be won. The culmination of this strategic and psychological tension would come in a series of infamous raids in the autumn of 1943, exposing the fatal flaws in the American doctrine and, simultaneously, the utter depth of the American industrial commitment. The missions to the ball-bearing factories would become the turning point. The culmination of the strategic stalemate between the unescorted American bombers and the escalating Luftwaffe defense occurred on two pivotal dates: August 17, 1943, and, most decisively, October 14, 1943. Both missions targeted the heart of the German war machine, the ball-bearing plants in Schweinfurt. These facilities produced nearly all of the essential, high-precision bearings required for every German tank, aircraft engine, submarine, and artillery piece. Disabling them, the American strategists reasoned, would bring the Wehrmacht to a standstill. The first Schweinfurt mission was punishing. The second, known instantly and grimly as Black Thursday, was a disaster that almost ended the entire daylight bombing campaign. On October 14, 1943, a force of 291 B-17 flying fortresses of the 8th Air Force took off from England. Their objective was clear: obliterate the Schweinfurt production lines. The mission profile was identical to earlier deep strikes: fly as far as possible with fighter escort, then continue alone into the German interior, relying entirely on the combat box. The P-47 Thunderbolt escorts, limited by their fuel capacity, turned back near the German border, leaving the fortresses exposed hundreds of miles from safety. The Luftwaffe, having learned brutally from previous encounters, was ready. German radar had tracked the bombers from the moment they crossed the English coast. Field Marshal Hermann Göring had personally ordered the entire available fighter force, hundreds of Messerschmitts and Focke-Wulfs, to concentrate on this single, high-value target. This was the largest, most coordinated mass interception the Americans had yet faced. The fighter attacks began over the border town of Aachen and continued relentlessly for hours. The German tactics were merciless and evolved: synchronized attacks by 3 or 4 fighter groups, employing the devastating head-on approach, supplemented by the use of rocket-firing aircraft. The air above the Reich became a brutal maelstrom of contrails, flak bursts, and burning aircraft. The B-17s, packed tightly in their formations, offered a massive, visible target. The crews, despite their electric suits and the relative warmth in the cockpit, fought a battle of desperate endurance. The German fighters, meanwhile, engaged in repeated passes, often landing, refueling, and rearming several times during the hours-long transit of the American force. This was a war of endurance. American logistics versus German tactical zeal. The losses mounted at an unprecedented rate. Bombers were seen exploding, falling out of formation, or descending in steep, unrecoverable dives, trailing fire and debris. The noise inside the surviving aircraft was deafening. The roar of the engines, the constant chatter of the intercom, and the nonstop mechanical hammering of the defensive .50 caliber machine guns. The German pilots, fueled by desperation to protect their homeland, pressed their attacks closer and more violently than ever before. By the time the remaining B-17s reached the target and dropped their bombs, the formation was shattered. Navigation aids were destroyed, crews were decimated, and the once impenetrable combat box was reduced to scattered groups fighting desperately to survive. The cost was astronomical, an unbearable measure of the strategic risk inherent in the deep penetration doctrine. The return journey was even more harrowing, fought by exhausted, battle-shock crews and damaged aircraft, many leaking fuel or operating on fewer than 4 engines. The catastrophic tally and the German discovery. The survivors of the Schweinfurt mission began landing back in England late that evening, struggling onto the airfields of the mighty 8th. The final tally was horrific. 60 B-17s were shot down over enemy territory. 5 more were so severely damaged they crashed upon landing or were immediately salvaged for parts. Over 600 airmen were killed, captured, or missing. A further 17 aircraft suffered major damage. In total, over a third of the attacking force was destroyed or rendered non-operational. This single day's losses exceeded the combined losses of the entire 8th Air Force in previous major raids. The commanders in England were faced with a crisis. The deep penetration bombing doctrine, relying on the B-17's self-defending capability, had been brutally invalidated. The Germans had proven they could inflict unacceptable, crippling losses when allowed to concentrate their defense without fighter interference. The daylight bombing campaign, the core of American strategy, was immediately suspended for deep targets. The U.S. command had reached its technological limit. They could not continue to send men into this meat grinder without a long-range escort. But for the Luftwaffe pilots and ground crews at the heart of the Reich, a different realization was taking hold. As they surveyed the vast, smoking debris fields across Bavaria, they began their own brutal inventory. Oberleutnant Richter and others like him had the opportunity to examine the complexity of the downed American machines up close. The focus was initially on assessing the armor plating, the powerful .50 caliber weapons, and the internal design that made the bombers so difficult to bring down. What struck the engineers and pilots was not the size, which was expected, but the internal systems. They found the advanced avionics, the robust oxygen supply networks, and the intricate wiring for the electric heating suits. Then came the discovery of the extensive exhaust gas cabin heating system. The sight of the dedicated ductwork, the insulated manifolds, and the vents near the crew positions caused a moment of genuine, disbelieving consternation among the battle-wearied German mechanics. To the German military mindset, which was rooted in the grim efficiency of Zweckmäßigkeit, suitability for purpose, this was an extravagant, almost unbelievable luxury. Their fighters had no such system. The pilots suffered the cold because it was deemed necessary for performance and weight reduction. The reality of the heated cabin was the physical manifestation of the boundless material wealth of the United States. It meant the Americans could afford to dedicate engine power, weight, and critical aluminum to ensure their men were comfortable, not just alive, but functioning optimally. The inspection of the captured wreckage became the turning point in German psychological understanding of the war. They had won the tactical battle over Schweinfurt, forcing a temporary halt to the raids. But the realization of how the Americans built their war machines, with systems that prioritize human performance through abundance, revealed the chilling, strategic truth. The Luftwaffe was not just fighting airmen. They were fighting the entire, inexhaustible productive capacity of the American industrial machine, which saw fit to include comfort as a non-negotiable component of combat readiness. The fight was not a fair duel between two equal powers. It was a desperate defense against an economic colossus. The men who flew in frozen cockpits realized that their enemy flew in relative warmth. The ultimate lesson of Black Thursday was not the American loss, but the German comprehension of the American resource advantage. This devastating mission forced both sides to radically rethink their strategy, leading to fundamental changes that would define the air war's final outcome. The profound losses of Black Thursday led to an immediate, strategic shift within the 8th Air Force Command. General Ira Eaker, the commander, had championed the concept of the self-defending bomber, but the Schweinfurt disaster demonstrated that this belief was untenable without dedicated long-range protection. The daylight bombing offensive against deep German targets was effectively suspended for several months. This pause gave the Germans a desperately needed, if brief, reprieve to repair the damage inflicted on their industries. But the American strategists used the hiatus to implement a solution that had been evolving in the design studios for years: the long-range escort fighter. The need was for an aircraft capable of flying the entire route, from Britain deep into Germany and back, with the bombers ensuring their protection during the critical deep penetration phase. The answer arrived in the form of the North American P-51 Mustang. Initially designed as a fighter for the RAF, it became a revolutionary weapon when fitted with the superb British Rolls-Royce Merlin engine. The Mustang possessed a potent combination of speed, high-altitude performance, and, crucially, incredible range. The addition of external drop tanks allowed the P-51 to fly over 1,500 miles, finally giving the bombers a protective umbrella for the entire length of the mission. The introduction of the Mustang in early 1944 fundamentally altered the dynamics of the air war. It did not merely escort the bombers. It was tasked with actively seeking out and destroying the Luftwaffe's fighter strength. The American command shifted its priority from simple escort to attrition of the German Air Force. The P-51 pilots were instructed to chase German fighters wherever they went, to their airfields, during their rearming, and in every phase of the interception. For the German pilots, the arrival of the Mustang was a devastating shock. Before they could anticipate the point where the American escort would have to turn back, giving them a free fire zone over the Reich. Now, the fast, agile Mustang stayed with the B-17s all the way to the target and back. Worse, the Mustangs were superior to the German interceptors at high altitude. This introduced a continuous, grinding pressure on the Luftwaffe that it could never escape. The air war transformed from a high-altitude slugfest between bombers and interceptors into a brutal fighter-on-fighter contest over the skies of Germany. The Luftwaffe was forced to engage the superior Mustangs repeatedly, leading to the rapid depletion of its most valuable resource: experienced pilots. German manufacturing could, for a time, replace the lost aircraft, but the loss of irreplaceable, highly trained airmen was a wound for which the Luftwaffe would never recover. The Schweinfurt losses had proven that the German tactical defense was potent. The response, the Mustang and its doctrine of aggressive pursuit, proved the overwhelming strategic depth of the American commitment, ensuring that deep penetration would resume with even greater destructive force, now permanently protected. This shift began the final, irreversible phase of the air war, moving toward the systematic destruction of the German Air Force itself. The numbers game, industrial attrition, and the final collapse. The ultimate consequence of the Schweinfurt raid and the subsequent introduction of the P-51 Mustang was the inescapable realization that the European air war had become a battle decided not in the cockpit, but in the factory. The seemingly small detail of the heated cabin was an index of a vast industrial disparity that guaranteed German defeat. To understand this gap, one must look at production statistics. In 1943, the year of the crucial Schweinfurt battles, the United States produced over 85,000 aircraft of all types. Germany, despite its dedicated total war mobilization, managed to produce roughly 25,000 aircraft in the same period. The American output alone, backed by untouched infrastructure and vast resource stockpiles, dwarfed the entire German capacity. This overwhelming advantage meant the 8th Air Force could absorb the devastating losses of Black Thursday, pause, re-equip, and then return stronger than before. The 60 B-17s lost were already being replaced by the time the P-51s were operational. For the Luftwaffe, however, the mounting losses of pilots were simply irreplaceable. The highly trained veteran airmen who understood the complex, high-speed dogfighting required to break up a combat box were being killed faster than the Luftwaffe's training schools could produce replacements. The relentless, continuous bombing campaign that resumed in early 1944, often called the Big Week, systematically targeted the very factories that produced German aircraft, fuel, and components. Protected by the long-range escorts, the B-17s and B-24s finally achieved the destructive precision that their doctrine demanded. The Luftwaffe found itself caught in an impossible loop. They had to fly to defend the factories, but by flying, they exposed themselves to the P-51s, accelerating the pilot losses that prevented them from defending the factories effectively. The German response, the desperate deployment of revolutionary, complex aircraft like the Me-262 jet fighter, only underscored the depth of their material crisis. These advanced weapons demanded immense resources and high-skilled labor, resources that were critically scarce. The Americans, in contrast, were fighting their war with sturdy, conventional, mass-producible machines like the B-17 and the P-51, whose systems, like the heated cabin, were built into standardized, repeatable production processes. By the summer of 1944, the Luftwaffe had been rendered virtually ineffective as an offensive force and severely degraded as a defensive shield. The skies over Europe were no longer contested. They were dominated by Allied air power. This air superiority was the essential prerequisite for the success of the D-Day landings. The difference was stark. The American crews, flying in relative, state-of-the-art comfort, were a product of an economy that measured victory in terms of sustained output. The German pilots, freezing in their cramped, stripped-down machines, were the product of a heroic but fundamentally unsustainable war effort. The heated cabin, therefore, was not merely a design feature. It was a statistical component. It symbolized the limitless capacity that allowed the Americans to turn the tide of air warfare from a tactical duel into a statistical inevitability. The German pilots could not believe the luxury, because that luxury represented the industrial power that was about to crush them. The story of the heated cabin is not a footnote in the history of aerial combat. It is a profound lesson in the nature of modern, industrialized warfare. The initial shock and disbelief of the German pilots, men hardened by years of desperate fighting, at finding comfort systems aboard an enemy bomber revealed the chasm that separated the two great powers. The war in the air was ultimately a reflection of two contrasting national philosophies. Germany fought a brilliant tactical war, emphasizing speed, technical superiority, and the heroic ability of the individual pilot to endure hardship. The United States, conversely, fought a war of engineering depth and logistical supremacy. The American bomber was not just a weapon. It was a complex system designed to ensure the optimal performance of the 11 highly trained men inside. The heated cabin, the electric suits, the complex oxygen systems. These were expensive investments, but they guaranteed that the bombardier's fingers remained supple enough to turn the precision knobs of the Norden bomb sight, and the gunner's mind remained clear enough to track a Messerschmitt closing at 500 miles per hour. In the final accounting, the war was won not by a single act of heroism, but by the relentless industrial capacity to build a million small advantages into every machine. The German focus on minimal, elegant design was defeated by the American commitment to maximum, sustainable output. This difference meant that while German designers were stripping away every unnecessary ounce of weight, American engineers were adding the weight of comfort systems because they could afford to, and because they understood the crucial link between human well-being and combat effectiveness. The B-17's cabin heater was the ultimate symbol of the arsenal of democracy. It represented a nation that possessed such a staggering surplus of material wealth, of steel, aluminum, fuel, and electrical components, that it could afford to fight its most brutal war in relative warmth. When Oberleutnant Richter felt the cold metal of that exhaust duct on the down bomber near Schweinfurt, he was touching not just a piece of engineering, but the cold, hard reality of American industrial might, a power that the Third Reich simply could not contest. The lesson persists. In a war of attrition, logistics often transcend tactics. The inevitable collapse of the Luftwaffe demonstrated that no amount of courage or tactical genius can overcome an enemy whose resources are limitless, and whose machines are built not just to destroy, but to endure. The sky was conquered because America built its war machines to keep its fighting men warm.